Hello everyone. Today we are dealing with a new section of the chapter number 12, that is area related to circles, and the section is areas of combinations of plane figures. That means here we will be dealing with finding out the areas of certain combinations of figures which we are using in day-to-day life, such as flower beds, then window designs and designs of table covers. So let's start with exercise 12.3. The first question is, find the area of the shaded region if PQ is equal to 24 centimeter, PR is equal to 7 centimeter and O is the center of the circle. So the circle is given in the question and the shaded region, you can see this portion is the shaded region and you have to find out the area of this region. For that, what we will do is, we will find out the area of the semicircle first and then subtract the area of triangle from that in order to get the area of the shaded region. Okay, area of the shaded region is equal to area of the semicircle minus area of triangle, which is the triangle here QPR. Okay. So first let's see what is given. PQ is given as 24, this length you know and this length also you know. That means it is a right angle triangle. Why it is a right angle triangle? Because this angle QPR is an angle inscribed in a semicircle. You have angle QPR is equal to 90 degree since it is angle inscribed in a semicircle. Okay, angle in a semicircle is every time 90 degree. So that you can say that the triangle is a right angle triangle also. Now since it is right angled triangle, you can use the half BH formula for finding out the area of the triangle. Okay, therefore triangle QPR is a right angled triangle, is a right triangle. Okay, hence you can find out the area of triangle QPR as half BH. So this will be acting as base and altitude. You don't need the hypotenuse here. So half BH will be half into 7 into 24, which is 84 centimeter square. So you got the area of the triangle. Now our purpose is to find out the area of the semicircle. And for semicircle's area, we need what is radius of the circle, right? And we can find out this is acting as a diameter. QR will be the diameter of the circle, so that you can find out the radius also. Now how will you find out QR? By using Pythagoras theorem, because it is 90 degree here. So since it is a right angled triangle, by Pythagoras theorem, what will be QR? QR will be root of 24 square plus 7 square, which will give you root of 576 plus 49, which is 625. That is, you are getting QR to be 25 centimeters. Okay. Now since QR is 25 centimeters, what about the radius of the circle? Therefore R is equal to 25 by 2 centimeters, right? Now we will be finding out the area of the semicircle. Therefore area of the semicircle is equal to half the area of the circle, that is pi r square is the area of the circle by 2. Pi you can take it as 22 by 7. So 1 by 2 into 22 by 7 into r square. R is 25 by 2. So you will get 25 by 2 the whole square, that is 25 into 25 by 2. 2 into 2 in the denominator. So that you can cancel this, you are getting 11 and you are getting 625 by 7 into 4, 28. Right? 625 into 11 by 28. Now how much the value will be is, you will get it to be 6875 in the numerator and 28 in the denominator. So this much is your area of the semicircle. Now what you need to find out? Area of the shaded region. Therefore area of the shaded region is equal to area of the semicircle, which is that we have already written. So substituting in 1 we are getting. Okay, therefore 1 becomes area of the shaded region equal to 6875 by 28 minus area of the triangle, which is 84. Now after taking LCM, what you will get is 6875 minus 84 into 28 divided by 28. That is 6875 minus what is 84 into 28? 2352. Divided by 28, and the value for that you are getting it as 4523. 4523 in the numerator divided by 28 centimeters squares. So this is the area of the shaded region. Okay. Question number 2 is find the area of the shaded region in the figure if the radii of the two concentric circles with center O are 7 cm and 14 cm respectively, and angle AOC is given to be 40 degrees. So you can just see here the figure, angle AOC is given to be 40 degrees, and you have to find out the shaded region ABCD or ABDC, right? This is the shaded region. So this, in order to get this region's area, what we will do is we will just subtract the area of two sectors. Which are those two sectors? AOC, the bigger sector, minus BOD, this sector will give you this portion. Okay. So we will just write area of the shaded region is equal to area of the sector, that is your bigger sector, okay, sector AOC, minus area of sector BOD, right? So you will get that this region. Okay. Now what is the formula for area of sector? Pi r square into theta by 360. So theta by 360 is, theta is 40 for both the things, you have 40. So you will have 40 by 360 into pi r square. What is r for this sector is given to be, for the bigger one it is 14 square, minus here you have again 40 by 360 into pi r square will be 7 for the smaller circle. Okay, the radius of the smaller circle is given to be 7, and for the bigger one it is given to be 14. Now this is again for both the things, you will have 9 in the denominator. That means you will get 1 by 9 and pi in common from both the things. That 1 by 9 pi into 14 square minus 7 square, right? For easy calculation. Again pi is 22 by 7, so you will get 22 by 9 into 7 into 14 square is 196 minus 49, which is equal to again 22 by 9 into 7 into here you will have 147, right? Now you can cancel these two, this will go for 3 4s are 12, and here you will get 9, 49 and 7, and this will go and you will get 7 here. So totally you are getting here 22 into 7 by 3, which is equal to 154 by 3 centimeter square. So this is the area of the shaded region. Okay. Question number 3 is find the area of the shaded region if ABCD is a square of side 14 centimeter and APD and BPC are semicircles. So this point is P. Okay. So this is a given figure, and ABCD is given to be a square of side 14 centimeter, and you have these two semicircles. In order to find out the shaded region, what we need to do, we have to find out the area of the square and then subtract the area of these two semicircles. Now two semicircles with the same radius means it is one circle. So either you can take the concept as area of the square minus area of the circle, or you can use the concept area of the square minus 2 times area of the semicircle. Okay, both will give you the same answer. Now in order to get the radius of the circle, what is the area of the circle? Since the square is of side 14 centimeter, this point is acting as the midpoint. So here the radius will be side of the square by 2. Okay, radius r will be 14 by 2, which is 7 centimeter. So now you have radius with you and the side of the square. Suppose A, if you are taking side of the square 14 centimeter is given. Now we will find out what is the area of the shaded region. Now area of shaded region, directly we are just substituting. What is that? Area of region is shaded region is equal to area of square minus area of either two semicircles or you can say one circle. Okay, area of two semicircles. Now what is area of a square if the side is 14 centimeter? 14 square. So here you are getting 14 square minus again area of semicircle, two semicircles. Okay, so if I am writing one semicircle, it will be pi r square by 2, right? So it is two semicircle means 2 into pi r square by 2. So that will give you actually area of the circle alone. So 14 square, okay, here you can write a square. In the next step we will substitute this a square minus 2 into pi r square, that is a square is 14 square minus here you will have pi is 22 by 7, r square, r is 7, so 7 into 7. Okay, 14 into 14 minus this 14 into 14 is 196. Here you will have 22 into 7 which is 196 minus 22 into 7 is 154. So 196 minus 154 is giving you 42 centimeter square. So this is the area of the shaded region. Okay. Question number 4 is find the area of the shaded region where a circular arc of radius 6 centimeter has been drawn with vertex O of an equilateral triangle OAB of side 12 centimeter as center. Okay, so you have a circle with center O and an equilateral triangle also with side as 12 centimeter. You have to find out the area of this total shaded region. It includes what all things? You have an equilateral triangle together with a major portion of the circle. That means you can say major sector of the circle. When you consider this completely, this is the whole circle and this will act as a minor sector, right? So that minor sector has been deleted because it has been included in the triangle. So we will just take the shaded region, area of the shaded region as area of the equilateral triangle plus area of the major sector. Now you have radius with you, this is given to be 6 centimeters, so r is okay. Now for the equilateral triangles area also you have the side, okay, one side as 12 centimeter. So we can just move on to area of the shaded region, which is equal to area of the equilateral triangle OAB plus area of the major sector. Okay. Now for major sector you have r, but what about theta? Since you know that the central angle of the circle is 360 degree and for an equilateral triangle you will have each angle to be 60 degree. So this one is 60 degree, right? So for the central angle of the major sector, how will you get 360 minus 60? That is 300 degrees will be the central angle of the major sector. Okay. So the central angle, so you can just write here when you are substituting, you can just mention that the central angle for the major sector is 300 degrees. What is equilateral triangle's area? Root 3 a square by 4 plus here you will have theta by 360 into pi r square, right? Root 3 by 4 a square. What is a here? 12. So 12 square plus theta is 300. You got the concept of 300. Central angle of major sector is equal to 360 minus 60, which is equal to 300 degrees. Okay. So 300 by 360 into pi is 22 by 7 into r is 6. So 6 into 6. Here again I can just write it as 12 into 12 so that I can cancel it easily. Here you have 3. 3 into 12 will give you 36. So it is 36 root 3 plus here you will get 5, 6, 6, 6 get cancelled. So what you are getting 30 into 22 by 7, or you can say 36 root 3 plus 60 by 7 centimeters square is the area of the shaded region. Okay. Question number 5 is, from each corner of a square of side 4 cm, a quadrant of a circle of radius 1 cm is cut, and also a circle of diameter 2 cm is cut as shown in figure. Find the area of the remaining portion of the square. So this is the given figure. Here you can see 4 quadrants. So from each corner of the square means you have 4 corners. So 4 quadrants has been deleted. Deleted in the sense they have cut out one radius of one quadrant is given to be 1 centimeter. So you have 4 quadrants and a circle. In the middle you can see a circle that is also been deleted or removed, and its diameter is 2 centimeter. Now diameter of the circle is 2 centimeter means its radius is also 1 centimeter, right? So this is also 1 centimeter and the other circle is also having 1 centimeter as the radius. And remember one thing, if you have 4 quadrants of same radius, together will give you a circle, because a circle has been can be broken into 4 quadrants like. So these 4 quadrants are those things, those 4. That means when you mix or keep it together, you will get one circle. So here you have one circle together, your 4 quadrants, and one more circle. So actually, in order to get the shaded region, what you need to do is, from the area of the square, you have to subtract the area of 2 circles, or else you have to just find out area of 4. You can just see area of a quadrant is pi r square by 4, and 4 quadrants will give you 4 into pi r square by 4. So it is actually pi r square. So it is same as the area of the circle. Okay. So you have 2 circles area to be deleted from the area of the square for getting the area of the shaded region. Okay. So area of the shaded region is equal to area of the square minus area of, what you can say, shall I write 2, or else you just write area of the circle plus area of 4 quadrants. Okay. So area of square is area of square is 4 square, or you can say a square, minus area of circle, it is pi r square, plus area of 4 quadrants will be 4 into pi r square. Just see, 4 into pi square by 4. So again you will get pi r square. So a square means it is 4 square minus pi r square plus pi r square. So I can write it as 16 minus 2 pi r square. Now what is r given to be? R is 1, diameter is 2, or you can take the other thing, there also you have radius as 1 centimeter. So 16 minus 2 pi into 1 square. Okay, since r is equal to 1 centimeter. That is 16 minus 2 into 22 by 7, which is 16 minus 44 by 7, which is 112 minus 44 by 7, or you will get 68 by 7 centimeter squares as the area of the shaded region. Question number 6 is, in a circular table cover of radius 32 centimeter, a design is formed leaving an equilateral triangle ABC in the middle as shown in figure. Find the area of the design. That means you need to get this area which is shaded. For that, what we will do, find out the area of the circle minus the area of the equilateral triangle will give you the area of the design. Okay, and now finding out the area of the circle is easy because you have radius with you. Now in order to find out the area of the equilateral triangle, you need one side, a side of the equilateral triangle, and that is not given. So first purpose is to find out the side of the equilateral triangle. Now in order to get the area, or you can say the side BC, what we will do is, we are just taking the center as O. Let O be the center of the circle. Now you have ABC as equilateral triangle, that means this angle is 60 degree, right? This is 60 degree. And if you consider BC as the chord of the circle, from the same BC you have two angles, that is BOC and BAC. And we know that at the center of the circle, the angle inscribed will be the double of the angle inscribed on the circle by the same chord. So if it is 60 degree here, what will be angle here? 120, right? So this angle will be 120 degree. Now what we are doing is dropping a perpendicular from O. Suppose that point is taken as D. So this is 90 degrees, and again it will divide this into two. These two will be congruent figures, so that this is again 60. Now you can write that this is 60, right? This will be 30, right? Okay. Now if this is 60, let it be not there. If this is 60, this is 60, what we need only the 60 degree. Why? Because we need this side. BC is our purpose to find out. So if we are able to find out DC, we know that BC will be the twice of the length DC, right? So what we are doing is, first we are finding out what is the length of DC. For that, if you are taking this is 32, because this is given to be the radius of the circle. This is radius, this is radius. Here you have 32, here again you have 32 centimeters. So now when you consider one of the triangles, either this or that, what you will get, you can use opposite side by hypotenuse, which is sine 60 degrees. Okay, so from and OD perpendicular to BC also we have taken. Okay, now we are just taking the triangle ODC, finding out sine 60 degree, which is opposite side will give you DC by OC, and DC is you have to find out, and OC is given to be 32. Now what is sine 60 degree? Root 3 by 2. So you will get root 3 by 2 is equal to DC by 32, or DC is equal to, what you will get, 32 root 3 by 2, that is 16 root 3, right? So this is your DC, 16 root 3 centimeters. Now what you need to find out is BC. Therefore BC is equal to 2 times of DC, that is it divides it into two equal parts, that is from the radius to the chord it will divide it into two equal parts, or you can say it bisects the side BC, so that you will get 2 into 16 root 3, or you have 32 root 3 centimeters as BC. That means you got the one side of the equilateral triangle. Now you can find out the shaded region, right? So area of the shaded region, or you can say what is given, area of the design. Okay, area of the design is equal to area of the circle minus area of the equilateral triangle ABC. What is area of the circle? Circle's radius is given to be 32 centimeters, so you will get pi into 32 square, pi r square, minus area of equilateral triangle is root 3 a square by 4, and a, what you got to be a as the one side, which is 32 root 3 whole square by 4. Now for both the things you have 32 in common, taking out 32 square, right? 32, this is pi 32 square minus root 3 by 4 into 32 into 32 square into root 3 into root 3, which is 3. Okay, so you are getting 32 square in common. Here it is pi minus 3 root 3 by 4, correct? Now what is 32 square? 1024 into pi, the value of pi 22 by 7, minus 3 root 3 by 4 will be kept itself like that, because they have not given any value for root 3 to be substituted, so we just keep it like that. Now just multiply these things, you will get this into 22, 1024 into 22 as 22528, 22528 by 7, minus again this into this, 4 get cancels with 1024, and you will get 768 into 3, everything will give you 768 root 3 centimeter square as the area of the design. Okay. Question number 7 is, in the figure ABCD is a square of side 14 centimeter With center A, B, C and D, 4 circles are drawn such that each circle touches externally 2 of the remaining 3 circles. Find the area of the shaded region. So what is the meaning? First a square is given with side as 14 centimeter. So this one is given to be 14 centimeters. Then ABCD have been taken as the centers of 4 circles, and those circles are in such a manner that if you consider one circle, it will be touching 2 circles out of the remaining 3 circles. You have 3 circles remaining and this is touching this circle. So likewise you have those 4 circles there. Okay, and what you need to find out? Area of this region. When they are touching each other, this total is giving you the radius of these two together. That means it is 14. That means you will get the radius of the circle to be 7 centimeter each. For each circle you will have radius as 7 centimeter, right? It will be half of the side of the square. Now in order to get this portion, what you have to do? Area of the square, area of this square minus area of these 4 quadrants. Now again, while treating these 4 quadrants, if you consider them together, that is forming a circle, one whole circle. Or else you can make it as 4 into area of one quadrant. Okay, so let's start. Area of the shaded region is equal to area of the square minus area of, you can say 4 into area of one quadrant. Okay, now side is given to be, side of square is given to be 14 centimeter. So radius of the circle will be 14 by 2, which is 7 centimeters. Now we are getting area of square is 14 square, side square, minus 4 into area of one quadrant is given to be pi r square by 4. So you will get it to be a circle. Okay, so 14 square, which is 196, minus pi r square. Pi r square is 22 by 7 into r is 7. 7 into 7. So you are getting 196 minus 22 into 7, which is 154, and this subtraction will give you 42 centimeter square. So the area of shaded region is 42 centimeter square. Question number 8 is, the figure depicts a racing track whose left and right ends are semicircular. The distance between the two inner parallel line segments is 60 meter and they are each 106 meter long. If the track is 10 meter wide, find the distance around the track along its inner edge and the area of the track. So what all are given in the question, we'll see. This is the track, racing track, and the parallel lines, in between the parallel line segments you have 60 meter gap. So this is given to be 60 and they are each 106 meter long, means the parallel track. So since here you have semicircular shape, so till the parallel lines comes, that means suppose this, till this portion you have the length to be 106, remaining is the semicircular shape. Okay, and if the track is 10 meter wide, track is 10 meter wide means this width is given to be 10 meter. You have to find out the distance around the track along its inner edge. What is the inner edge? This one, this inner edge distance you have to find out. So for that you need this parallel length, this parallel length. So parallel length already given, this is 106 and 106, so 106 plus 106, and you need to get this semi, if you say circumference, semi circumference you want. Okay, so for that semicircular region, for that you need the radius. Now since this total is your 60 meters given, the half of this is 30 and that will be same as this and this will be acting as the radius of the semicircular region. So that will give you your 30 meters. Okay, and that is r. So what you need to find out? Distance, right? So distance around the track along its inner edge, is equal to, one thing is 106, twice you will take, so 106 plus 106, that is that length, parallel length which you are getting, plus you will have, here you have semicircular region and there also. Okay, so you can take 2 times of one semicircular region or semicircular region 2 times you can add. Now what is the semicircular region? The circumference is given to be 2 pi r. Here you will have semicircular region means it is 2 pi r by 2, which is pi r. So pi r plus pi r, right? Pi r is 30. So pi into 30 plus pi into 30, or you can take it as 2 into pi into 30. Here also you can take it as 2 into 106 also. Okay. Now replace the values. 2 into 106 plus this can be taken as 22 by 7. So 2 into 106 will give you 212 plus 2 into 30, 60 pi. Pi is 22 by 7, which is equal to, totally when you add you will get it to be 2804 divided by 7 after taking the LCM and all. And this is your distance, means it will be, units will be, it is in meters. Okay, so it is meters, track now. So it is in meters. This much of meters is your answer for the first subdivision. Now for the second subdivision, which is you have to find out area of the track. So this is the track. Here you can just split it into, this is your rectangular portion, that means where you have a parallel lines, this much will give you the rectangular region. So 2 rectangular regions you have the length 106 and breadth as 10 meter, that is the width is given as 10 meter. So that will give you 2 times of the rectangle as this much of region of the track. Now it is remained with this and this. Now again if you go for this one, if you have to get this region, you have to subtract which 2 regions? The bigger circular region minus the smaller circular region, or you can say semicircular region, right? And bigger semicircular region means its radius. What will be the radius? This much is 30, this is 10. So the radius of the bigger semicircle will be 40 and the radius of the smaller semicircle will be 30. So you will get pi r square minus pi r square, pi bigger r square minus pi smaller r square will give you the area of this semicircular region. And you have both the sides the same thing. So 2 times of the semicircular region plus the 2 times the area of the rectangular region will give you the area of the track. Okay, so first we will find out what is the area of the semicircular region. Which will be, you understood, the capital R will be 40 centimeters, that is 30 plus 10, which will give you meters, and small r, so small r is 30 meter. Now you have area of semicircular region as pi r square by 2. Pi r square is the circular region's area, so pi r square by 2 semicircular region's area minus pi small r square by 2. So pi by 2 can be taken out. This is r square minus r square, which is equal to pi by 2 into 40 square minus 30 square, which is equal to pi by 2 into 1600 minus 900, which will give you pi by 2 into 700. Now what is pi? 22 by 7 into 2, here you have into 700, which is 100. So you are getting 2200 divided by 2, which is 1100 centimeters square as the area of the semicircular region. Now we will find out what is the area of the rectangular region. Area of rectangular region. Again, that region means you have 2 regions, so we will take at a time 2 times of area of the one rectangular region, and area of rectangular region is length into breadth, so that you will get 2 into what is length 106 into breadth is 10. So you will get 2 into 1060, or how much you will get? 2120 as the area of the rectangular region. So adding the 2 will give you the area of the track. Therefore area of the track is equal to 1100. This is actually one semicircular region. So for 2 semicircular region you have 2 into this region. Okay, so you have 2 into 2 times the area of the semicircular region plus 2 times the area of the, that has been already taken there, so it is 2120. which is equal to 2200 plus 2120, and that will give you the answer, final answer as 4320 meter square. Here understood, this is 2 into the area of this is one semicircular region, there also you have, so it will become 2 into, here already for the rectangular region I have taken this 2 times, so I have just added this. Okay.